Well, this demonstration is to implement the Euler's forward difference algorithm for the same problem dy dt equal to y minus t squared plus 1, and we developed the calculation strategy in Microsoft Excel and we implemented that. Let's see the how simple is going to be the program for the Euler's forward difference method. So at first, let me define the a function. So I define it that this function is going to be f of ty, and it should be on dependent upon t and y. So I call this function fty, and this function should return a value that should be equal to y minus t squared plus 1, and here is going to be the return a value. So that is function definition, the right hand side of the equation, differential equation. Now we have the domain for t. So I write here t, the initial value a is 0 and the final value is equal to 2, that is for time. And let's define a step size equal to 0.2. So this is step size. Initial t, final t. And now let's define the number of points. So n value. So I define it like integer b minus a divided by h. The number should be generated as integer. Now, okay, I must have the libraries numerical Python and the plot library. So I write here import numpy as an e, import matplotlib.py plot sdft. So libraries n has been generated. Now let's define the t value. So t value numpy, here I write linear space from a to b and with n number of points. Okay. Then this is the t vector. Now let's generate a vector for y. So for y we should have the exact values. Not should have. We can calculate the exact values. So I write here numpy zeros, and I write there should be n values and all should be the real numbers. So it's a vector for comparison. This is for y exact or analytical answer that is available to us for this problem. And y computational or numerical, let me first set the values and float zeros. So y from computation or Euler's method implementation. So now the initial condition. So this should be the first value of y. So y of 0 as per Python convention. The first index should be this one. And the value for our problem is 0.5, y of 0. The time first value is also 0. Okay. So I can write here, this is the initial condition. Now from the first calculation, we can move on to to compute the endpoint values. So I write here for I in range would start from 1 to n, and here we go that y of I would be equal to y of I minus 1 plus h times f dy, the function value of a value of t at the previous time and value of y at previous time. See how convenient it is to write just like the Euler's expression. So it is Euler's expression. Now for the calculations, well, it should be yc. Yc should be equal to yc, and here it should be yc. Okay. That's for comparison. Well, we can do that one outside the loop, no problem. Python works with the vectorized programming. So now y exact will be equal to value of y squared no exact answer, sorry, exact answer is equal to t plus 1 squared. So I write the squared value minus 0.5 times e raised to the power t. So I write the numpy function exp of t. So for the whole vector, this new vector y e will be computed at all the points of t. Point by point, it will be calculated. So it is the vectorized calculation. So this is the y exact. And now the plot. So I can write plt plot t. I want to compute, want to plot ye exact one. So let's plot it as, and also on the same one, let's plot y computation, and with red dots, and that's it. And then write plt x label as time, it was time t, plt y label as y. That is the additional capability that we have in Python or in MATLAB or in others. PLT final show. So this is the program. I used a function definition for the right hand side, and in order to develop further programs, you have to just intelligently update the part which is in this loop. So 3 lines, no, 2 lines. 2 lines are here. The rest of the program will remain the same. You have to have a proper description of the function, and that will suffice for your job. Let's see the working of this program. So for that, I will run the module. The program should be saved, and then it will run. Let me take you to the window where it is working. And there should be no cry, no sigh. Okay, there is some spelling mistake. So again, the strange experiment I have to correct in line number 10. When you do the programming, you should be willing to correct your small mistakes. So import line has some problem. This is the first error. Let's go to program and correct it. Okay, mat matplot matplotlib.pyplot. Okay, save the program and run it, and there should be no cry, no sigh, no coughing, no whistle, and where should we go? Yes, here we are. The program ran successfully. Hopefully you can see that, and I can show you the plot. Okay, so here it is. We have the exact answer, and we have slightly deviating from the answer is the Euler's forward difference method.